the problem we'd left you with. If you haven't tried solving it, pause the video and give it a shot. Okay, ideally, Zen shouldn't be doing that. But now that he's done it, let's solve this problem. Word problems always get easier with diagrams. Say this is the ground level, and this was the initial height from which Zen threw the calculator upwards. The initial velocity u is given to us as 20 meters per second. That's the velocity at which Zen throws the calculator upwards. After Zen throws the calculator up, it will reach a certain height and fall back towards the ground. And that's because of the gravitational pull of the Earth. When the calculator is at the top just about to fall down, its velocity will be 0. So the final velocity v will be 0. We've been asked to find the height at which it reaches before it begins its descent. Now, which equation of motion do you think will give us the value of the height? It'll be the third one. v squared is equal to u squared plus 2as. Here a will be the acceleration due to gravity and s will be the distance the body has covered. In this particular example, s will be the height to which the calculator travels just before it begins its descent. Now we're coming to a very important point. What will be the value of a? We know that the acceleration due to gravity is 9.8 meters per second squared. Don't forget one important thing. Velocity and acceleration are both vectors, which means that they have magnitude as well as direction. In this example, the velocity is in the direction opposite to the acceleration. Velocity is upwards and the acceleration is downwards. So here, the sign of the acceleration will be opposite to that of the velocity. As we've assumed the velocity u to be 20 meters per second, the acceleration a here will be negative 9.8 meters per second squared. Substituting these three values in the equation of motion, we get this. Solving this further, we get the value of s as 20.408 meters. This is the height to which the calculator reached before it began its descent. And this height is from the point at which Zen threw his calculator, not from the ground.